Alrighty, see what we got today. Minimum index of a valid split. An element x of an integer array of length m is dominant if more than half of the elements of the array have value x. Dominant if more than half of the array have value of x. Okay, let's say there's like a dominant value. You're given a zero index array nums of length n with an element array. Okay, x is not okay. You're given and there's a dominant element. You can split nums at index I into two arrays, but the split is only valid if I is some index within the array. Okay, and 0 nums from 0 to I and nums from I plus 1 to the end have the same dominant element. Interesting. Here, nums of I to j denotes subarray nums starting at index I and index j, both ends being inclusive, particularly if j is less than I, nums at I to j denotes an empty subarray. Sure, particularly if j is less than I. Is I bigger than okay. Okay. Return the minimum index of a valid split. If no split exists, return -1. So you can split it up into 1, 2. Okay, so dominant just means that it's the most frequent, and it cannot be tied more than half, so it can't just be half. So here, if you split it into two subarrays, 1, 2, 2, and 2, they're both dominant with the value of 2. Here, the output is the index. Return the minimum index of valid split. Okay, so the first index where you can split it. So index 4, 0, 1, 2, 3, 4. So index 4 is this index. Okay, you can't do index 3 because even though 1 is the most frequent one, it's not the more than half. It's not frequency, it's more than half. Yeah. So index 4. Okay. And here you can do index. Why can't you do index 1 here? There's no valid split. If you do index 1, shouldn't you get 3 and 3? Split is only valid if 0 and they both have the dominant index. More than half. So no. Why can't you do 3 on the last one? Or why can't you split it on 3? On the first index 1. Because you could split it on index 4 here. Or index 3. 0, 1, 2. We split the array at index 2. Okay. In array 2, the element 2 is dominant. The minimum valid index is index 2. Shown that there's no valid split. Split is only valid if nums from 0i and nums from I plus 1 onwards. Here nums I to j denote subarray starting at index I and index to j, both ends being inclusive. If j is less than I, why would j be less than I if it goes I to j? I don't understand that last comment. zero index nums with one dominant element. Like, why can't you? Oh gosh, I keep on thinking it's the most frequent one, but it's not frequency. It is more than half. More than half. 3 is occurring exactly half. Okay. So I think first off, the most dominant, if you do a split, it has to be, we can figure out what the most dominant value is as the most frequent value in the array. If it's not the most frequent, then, or if there's a tie in the frequency, then there's no way you can split it up. Because it has to be even more than half, or both halves. So I think I can, how to determine the most frequent one. You could do a counter and then sort the counter. Is there a faster way of determining frequency than that? Do a counter and sort the counter. You can do a counter and just find the maximum frequency within the counter. Okay, so let's start with that. Counts is equal to counter of my nums, and then for every value frequency in counts, let's go dom is equal to -1, dom frequency is equal to 0 for each value and frequency in counts. It might be counts.items actually. I think we'll try this right now. If the frequency is greater than the dominant frequency, what if there's a tie? If there's a tie, then it's not going to work. And what the start the values between, okay, the values are between 1 and a million, or 10 to the 9th. Okay, so if the frequency is greater than or equal to the dominant frequency, then I'm going to say, okay, if the frequency is greater than the dominant frequency, then the dominant value is going to be this value, and the dominant frequency would be this frequency. Else, if it's matching, then this is not going to work. So we're going to say the dominant value is actually invalid. And then I guess you could do just a check at the end to see if it's greater than or equal to half the array. Yeah, you can do a check at the end, greater than half. Does that be greater than half or greater than half plus 1? Oh, whatever. And then, well, there's only one possible value. Actually, yeah, there's only, if the frequency is greater than, let's say there's n numbers, it needs to be greater than half plus 1, right? you need to have, so it could be yeah, it has to be greater than a half plus 1, greater than or equal to. If frequency is greater than or equal to n divided by 2 plus 1. So if it's 3, half of 3 is 1, greater than 1 is, that's 2. I need to round up, because if it's 3, then all 3 has to be the same. If it's 5, 5 divided by 2 is 2, plus 1 is 3. Can you do it with just 3 and 5? I don't think you can. I don't think you can split up 3 and 5, so it has to be like at least 1 is 1, and then the other side is 4, is 2 is 4, 2 of 4. So it doesn't work, so I think it has to be rounded up. So I think it's like n plus 1 divided by 2. And then that's going to round up, and plus 1. And the dominance value is this, and then I can say break. And if the dominant value is equal to -1 at this point, then you can just return -1. Let's go ahead and print the dominant value, see if this works. Alright. Yeah, okay, so for every value in counts, the frequency of that value, which is counts at this value, okay, so it didn't print out -1 here, which is unfortunate. N is 4, 4 divided by 2 is 2, 4 plus 1 is 5, 5 divided by 2 is 2, 2 plus 1 is 3. If the, alright, why wouldn't this print out? Oh yeah, it does print out 2, okay. And this one prints out 1. Yeah, this one was possible, and this one was not possible, okay. Alright, so this is determine dominant value needs to have at least half plus 1, half round up plus 1 in order to be at all splittable. And if it is, at least if it does find it, so if you found your dominant value, then the earliest index whereby the earliest, so if there is a dominant value, there should be a dominant way to split it. So wherever you find it's going to be earliest. Yeah, it's just going to be just go through the loop, and then at any index where you have more than half of that value in that half, more than half of that value in that half, then in that subarray, then the other half should also work. So for every index in the range of n, the value is equal to the nums of this index. Let's go ahead and say the count. If the value equals the dominant value, then the count goes up. And then if this count is greater, if this count times 2, so if this count times 2, there's other ways to logic this, but is greater than the index that we're at. So let's say it's the basic, just you start off with the dominant value. So there's going to be 1 is the count. So let's do an example here. Let's say it's 1. Let's say the most dominant one is like 5. So 5, 5, 5, 1, 2, 5, 5. No, you need another 5. So the count times 2 is greater than the current index. And then we return this index. I don't think this is quite right. So it's greater than index plus 1. Because you could have 1, 5, and you don't want to break at the 1, 5. You don't want to break at this 5. So even though the index is 1, you need to have 2 of them. So yes, I think it's greater than index plus 1. There's other ways to maybe do this logic with division of the index. So at index 3, or at index 2, 2 plus 1 is 3, count is 2, 2 times 2 is 4, 4 is greater than 3. Okay, and let's look at the other test cases. So here, yeah, that's fine. Here, you need to go to index 4, 0, 1, 2, 3, 4. 4 plus 1 is 5, and you have 3 ones. 3 times 2 is 6, 6 is greater than 5, that's right. And here, you would try to stop at the first one. Does this have a dominant value? There's no dominant value for this one. Okay, good. Or there's no possible dominant one that's more than half rounded up of the array. Okay, I think this is fine. I think that's it actually. Return -1. I'm not even sure the last return is necessary. Okay, cool. Yeah, I don't think it's necessary because this check, I'm pretty sure guarantees that there's going to be a solution. And this is just about finding where the solution resides. Okay, cool. Alright, so summary of the algorithm. This is just, you need to first determine most frequent. And we'll use it, using counter method to get frequency array. For the frequency array is the number and the frequency of that number in a mapping. And then determine based on min frequency of a size n array. This is the rounded half round up plus 1. To get to see if it's possible, and what the value is. Then go through array to find first index where the frequency of value is higher than half that subarray. Other half will auto-satisfy. So you're just trying to find the minimum, the earliest one in the first portion of the array where more than half of it is of that most dominant value, and based on the logic of how many elements are remaining and how many dominant elements are total, it's still going to satisfy the same one. This is a time complexity of O of n for getting frequencies. The frequency counter mapping will go through at least one pass of the whole array. Also, for getting the frequency counter for the dominant for determining dominancy, and for determining earliest index. All those are doing like one pass of the whole array. And then lastly, space complexity. This is going to be O of, there's also O of n for the mapping. There's no extra space for anything else. Alright, cool beans.